All right, today we're going to work on solving quadratics by completing the square. And when we do that, we're going to create equations that look like what we have here as a review example. So I'm just going to go through this with you really quick. You would love to have parentheses squared in a question. You don't want to FOIL. We're not trying to put this in standard form. What I'm going to try to do here is get the parentheses by themselves. And if I go ahead, get rid of any addition or subtraction first, I'm going to add 12 to both sides there. And if I do that, I'm going to get 400. Don't distribute, you want to divide anytime you have parentheses with an exponent. And I'm trying to get these parentheses alone. And the reason I'm doing that, we're not foiling, I can cancel the parentheses out. They're squared, so I can just take a square root. Now, the one main thing you always want to remember here, when you introduce a square root into a problem, there's two answers, so you have to put that plus and minus symbol. So this is nice for us because 100 is a perfect square. So answers here could be 10 or negative 10. Now I'm just going to use this space here a little bit. I got to get the x totally alone, so I'm going to subtract the 3. So I'd have negative 3 plus or minus 10. So my two answers here, negative 3 plus 10 would give me 7, and then negative 3 minus 10 would give me negative 13. Those are my two answers there. So what we're going to get into today is trying to create a situation where we've got some parentheses and we can just take a square root like we did in that example. So just a couple little review questions. We've mentioned these before. But what a perfect square trinomial is a situation where both factors, if we put it in factored form, both factors are the same. So if we think about factoring here, right, multiply to get 25, add to get 10, you would tell me that your factored form there, multiply to get 25, add to get 10, x plus 5, x plus 5, and the reason we like this is because since they're the same, we can squish them together and write it as x plus 5 squared, and then it's going to create a look like what we saw in that equation we just worked through. Similar concept here, just a little different. This is a plus plus, this is a minus plus, so to multiply to get 49 and add to get negative 14, both of these have to be negative 7. So negative 7 times negative 7 turns into a positive 49, and negative 7 plus negative 7 will add up to negative 14, and we can squish that together, write it as x minus 7 squared, creating something that we can use to help us solve the equation. Now, what I call the magic number. So some of these questions won't just give you a perfect square trinomial, so there's a process you can use to create one and make the equation easier for yourself to solve. So if I have the form ax squared plus bx plus c, what you want to do to create a perfect square trinomial is take that b value, divide it by 2, and square it. And you want that to be the c value when you're working with these to create a perfect square trinomial. So I'm just going to show you how this works down here in example 1. So I literally have just like a blank spot. So it says find the missing value to complete the square. So what you're looking at is the number with the x attached to it, so 20x in this case. So my b value is 20, you divide that by 2 and square that. So 20 divided by 2 is 10, squared is going to be 100. And then what I'm trying to do there, multiply to get 100, add to get 20, and your factored form there, you're going to end up with, I'm going to write 2 steps here, you're going to end up with x plus 10 times x plus 10, or what we want to solve these equations, x plus 10 squared. Sorry, I'm off the screen a little bit. 10 times 10 is 100, 10 plus 10 is 20, and you can see we created that perfect square trinomial. Okay, now the one in the middle here, the b value for this one is negative 8. So I'm just going to take negative 8, divide by 2, and squared. Whenever you square a negative number, that will always become positive. So whatever you add here to create a perfect square trinomial, it will always be adding. You'll never be subtracting something. So this is just going to be what I'm going to write down here, which is 16. Now, if you want to think about this, I got to multiply to get 16, and I got to add to get negative 8. It's going to be x minus 4 times x minus 4, or what I'm going to write down here, x minus 4 squared. Now, what I want to go back and point out to you just really quickly, whatever you get for your factored form is related to what you do in that process for finding that number. So if you guys look back here, I ended up squaring 10, and that ended up being my factor. Here, I ended up squaring negative 4, and that ended up being the number in my factor. So whatever you square, after you simplify that, you take your b value divided by 2, whatever that is before you square it, that will always be the factor. So that's what I want you guys to keep in mind for this last question, because this one's a little trickier. So my b value here in this last example is a negative 3. Okay, so I'm doing negative 3 divided by 2 squared. Now, unlike the previous two questions, this actually divided. Negative 3 is not divisible by 2. So here's what you want to do. Just go ahead and square both of these numbers. So I'm going to do negative 3 squared, and I'm going to do 2 squared. So this is going to become 9, and this is going to become 4. All right, so that's what I would put in place here. And remember what I just mentioned to you on the last question, whatever you square is going to be your factor. So if you do, I know this is a little odd, I need to multiply to get 9 over 4, and I need to add to get negative 3. If you do negative 3 over 2 plus negative 3 over 2, this gives you negative 6 over 2, which is the negative 3. And if you multiply negative 3 over 2 times negative 3 over 2, that gives you positive 9 over 4, which is what we had up there. So this number is going to be fitting both requirements, and I'm just going to leave it as a fraction. So your factored form here would be x minus 3 over 2 squared. And I know that's tricky, but if you remember this little trick here, it's always the same as what you have squared. Okay, now I'm on the back page, and the directions at the top here is just a general step-by-step instruction for how to complete the square. Now, we're not going to deal with any where we have a number in front of the x squared in this situation, because if that happens to you, there's easier ways to solve a quadratic equation than using this method. So that very first step says that a value has to be 1. So if you come down here, like this is just a plain x squared, that's what you're going to see. So you don't need to really worry about that. But if you do run into an equation and the number in front of the x squared is something other than 1, you can't use the process I'm going to show you right now. So just want to point that out. Okay, what we're going to do is we're going to set these up, and we're going to do what we did in that example and add that magic number. But since on these questions we're working with equations, we're going to add that to both sides to keep that equation balanced. So I'll show you that in a second. Then we're just going to write the factored form. We'll take the square root of both sides, and we'll be done. So first thing to do is make sure you have the term with the x squared and the x on one side and any other plain numbers on the other. So that's what I've already got here. So when I set these problems up, here's what I like to do. I like to just make, almost like I did on that last example, like a little blank. And what I do is I put that on both sides of the equation so I don't forget that I need to add that magic number to both sides of the equation. Okay, so to create that, you're going to take the b value. For this question, it's 6. You're going to divide that by 2 and square it. So 6 divided by 2 is 3, and 3 squared is going to be 9. So I'm going to add 9 to both sides. If you've done that, you should have created your perfect square trinomial. So if I want to factor this, which this should now be factorable, I got to multiply to get 9, and I got to add to get 6, and whatever you squared is always going to be the factor, so this fits both of these requirements. It's going to be 3 and 3. So I'm going to have x plus 3 times x plus 3. This side, to keep the equation balanced, since I added 9 here to help me manipulate this to create a perfect square trinomial, I have to do that to the other side to keep the equation balanced. So this is going to go ahead and be 29 since we already had the 20 there. The whole purpose of doing this is so I can squish those two factors together since they're exactly the same. And then we can just solve the equation like that one at the very beginning. I'm going to take square root. So I still have x plus 3 here. The square root and the squared cancel each other out. Plus or minus radical 29. Now, if I could break this down, I would want you to do that. 29 does not have any perfect squares that divide into it. So here's what I'm going to do here. I'm going to subtract 3, and we're just going to have to leave it like this. Negative 3 plus or minus the square root of 29. And we don't want to do any rounding or anything like that. This is an exact answer. You just go ahead and leave it like that. These are two answers here. Negative 3 plus the square root of 29 and negative 3 minus the square root of 29. Okay, just going to give you guys a little example here that has an odd number so you can see what that looks like because it'll have a fraction. So I'm going to kind of set this up exactly the same way. X squared minus 9x, and then I'm going to leave a little space so I can complete the square. And I'm just going to leave that on the other side to remind myself whatever I do here, I got to add that to both sides. Okay, I'm going to take my b value, which here is negative 9. So I'm going to do negative 9 divided by 2 squared. Can't actually divide that, but I can square. So negative 9 squared is going to become 81. And 2 squared, excuse me, is going to become 4. So that's what I'm going to add to both sides. Okay, now whatever you square, this will be the factor. So the factored form of this is going to be x minus 9 over 2 squared. And we're going to have to add this together. So here's what I would tell you to do just real quick. If I add fractions, I have to get a common denominator, right? So negative 6, if I want to change that to a fraction real quick, I'm just going to write it over 1. And then what I'll do there is get a common denominator. I'll multiply the top and bottom of that by 4. And I'm going to just come over here. So this is going to be negative 24 over 4, which hopefully that makes sense. That's equal to negative 6. And then I'm going to add that 81 over 4. Now, if you guys remember, you want to leave these as fractions for me because it'll make it easier to do in the next step, I promise. Negative 24 plus 81 is going to be 57 on the top of the fraction, and then the bottom of the fraction is going to stay 4. When you add fractions or subtract fractions, that common denominator doesn't change. Now, I'm going to end up and take the square root of both sides. This is going to be x minus 9 over 2. Okay, now here I'm going to take the square root of the top and bottom separately. So 57 is not breaking down under a square root, so go ahead and just leave that alone. However, the square root of 4, I can actually take that square root. That's actually going to be 2. And then this is going to work out like this every time you do these problems. I'm going to add that 9 over 2 real quick to both sides. Okay, so x equals 9 over 2 plus or minus square root of 57 over 2. And if you guys want to, you can leave it like this, or these actually have a common denominator. So what you could do 9 plus or minus square root of 57 over 2. And if you guys remember at all doing the quadratic formula at any other time in Algebra 1 or before this class, the quadratic formula, we'll get to that eventually, the answers look something like this, and so that's what's going on here. This is just another way to do this problem with completing the square. Okay, now real quick down at the bottom, I'm just going to show you what we were working on yesterday. These questions are going to have what we call imaginary solutions because we're going to have an I in the answer. So I'm going to keep the same process. I want the x squared and the term with the x on the same side. I'll leave myself a little space here. And I'm going to complete a perfect square trinomial and add a number to both sides. To do that, I need the b value, which is 12 for this question, divided by 2 squared. So 12 divided by 2 is going to be 6, and when I square that, I'm going to get 36. So to both sides, we're going to add 36. Okay, factored form here, multiply to get 36, add to get 12. It's always whatever you square. So this would be x plus 6 times x plus 6. Or, what we really want is to squish that together, x plus 6 squared. This added up would just be negative 4. And you guys remember, we want this, don't want to FOIL it, we want it so we could cancel it out. So I'm going to get x plus 6. Now, because this has a negative under the square root, and it's actually a perfect square here, just in imaginary land, if we have a negative, I'm just going to put an I. So square root of 4 is 2, and that negative is going to make it an I. So we just write plus or minus 2i. And I want to get the x totally alone here. Now, this negative 6 is a real number, so I can't actually combine it with the 2i because it's got an I and this doesn't. So your answer is going to look something like this, negative 6 plus or minus 2i, and it's actually two answers because it's negative 6 plus 2i, negative 6 minus 2i. And then just one more to show you that's got an odd number so you can see that. X squared plus 7x. Leave a little space to complete your square. Okay, now I'm going to take the b value here, which is 7, divided by 2 and squared. Now, here can't actually divide that, but I can square it. Both of those numbers squared, this would be 49 over 4. So I'm going to add that to both sides. Okay, my factored form here, whatever you square, that 7 over 2, that is your factor. And then here's the tricky part. So I need to change this negative 16 into a fraction with a common denominator. So I'm going to write that over 1. We'll just do a couple steps here. I'm going to multiply here top and bottom by 4 to get a common denominator. This will be negative 64 over 4 plus 49 over 4. Slide that up a little bit so I got some room. Just going to grab my calculator here. Negative 64 plus 49. I'm going to give you, oh, not on the screen, sorry guys. I'm going to give you negative 15. Okay, so here I have negative 15, 4, and that x plus 7 over 2 squared. Now, this just like the last problem, except I've got a negative under the square root. So I can't take the square root of the 15. That's not going to break down. But I can take a square root of 4. So this can be x plus 7 over 2 plus or minus. Here's how I'm going to write this. So I'm going to take care of that negative by putting an I out in front of that radical 15. And you can actually take the square root of 4. That's 2. Now, this is just like the last problem. When you subtract this from both sides, minus 7 over 2 here, you get negative 7 over 2 plus or minus I radical 15 over 2. And you can leave it like that, or these actually have a common denominator, so I can put them together. Negative 7 plus or minus I radical 15, the whole thing, over 2.